some fractions. This whole chapter that we talk about here in chapter 7 is going to be regarding fractions. And so I want you guys to get a little bit of some refreshing yourselves on these notes about fractions. Good morning. Morning. George, we're taking a quiz. It's on the screen. You got 3 questions. All right, your outlandish bonus question's up at the top too. So after you work these 3 questions, you can answer that one. Take about 45 more seconds. Yes, sir. You're just now asking this, Joey? What the heck is wrong with you? You had your hand up. Call me if I'm not looking, dude. Let's be quiet back there. All right, you get this pretty pink pen. Ah! Blocked by the air conditioning unit. Hold on, let's try that again. Okay, got the heater. All right, here we go. Yeah! Almost. Now we're cooking. All right. So, with each of these quiz questions, there's stuff that we ought to be able to do at this point. Okay. Nothing too complicated. Just taking our time and simplifying out these operations. Okay. So, kind of give yourself a grade on this out of 3, right? And this is just meant to be. I'm not like recording these grades for you guys or anything, but this is just meant to be like a kind of a checkup, if you will. And if you don't do so hot on this, it's okay, but you got some work cut out for you because this chapter being all about fractions, we got to know how to do some basic operations on fractions, simplifying them, common factors on top and bottom that get canceled out, multiplying fractions where we multiply the top with the top and the bottom with the bottom, and then dividing by fractions, which we'll talk about on number 3. But this first one right here, what do you notice that goes in? What's the GCF of 90 and 15? 15. Okay. 15 goes into itself once, and 15 goes into 90. Well, let's think about it. 15 goes into 30 twice, and 30 goes into 90 thrice. So 2 times 3 is 6. So 15 goes into 90 6 times. And then, of course, we got our y on the top and a y on the bottom that we would cancel out. So we're left with 6 over y. 6 over y. Okay? Questions on number 1? I suppose the long way of doing this one, number 1, would have been to say 6 times 15 times y and 15 times y, and then just like visually canceling 1 to 1, and then you're left with 6 on top and y on bottom. That's another way of looking at it, right? Where you factor out the top and you factor out the bottom. Now that's going to be a very common thread this chapter. Notice what I just said. Factoring out the top is to write it as a product. Good. Factoring out the top and bottom is always a good idea. So with number 2, I would not multiply 14 times 6 and 15 times 35. Okay. Instead, I would perhaps consider writing it as a product of 2 times 7 times 2 times 3 and 3 times 5 times 7 times 5, right? So we factor out the top, write it as a product, and then we can start canceling some common factors. We notice a 7 gets canceled out. We notice that a 3 gets canceled out. And what are we left with? 4 over 25. Now, of course, we could have done that the quick way, like I said at the beginning, and this is what that would have looked like. We could have said, all right, 7 goes into 14 twice. It goes into 35 5 times. 3 goes into 15 5 times, and 3 goes into 6 twice. And then we multiply after the fact, 2 times 2 and 5 times 5. All right, so really, whatever way you slice it, that's how we simplify fractions. Am I 2 for 2 so far? Put your hand in the air if you think you're a player. I got about 4 or 5 of you guys, maybe. Okay. What has tripped us up so far? Voice your issues. What about it? I mean, that's what I'm saying. Did we forget the y? Was it we didn't simplify it down all the way? What do you think, Jack?
I think they covered one y.
You did what?
I think they covered one y.
Oh, that's okay. That's not wrong. Oh, so it's just you ended up with 4 over 5? Gotcha. Okay, yeah. So look, a lot of times what we're doing is we're looking for our own mistakes. We're saying, wait a minute, what did I do wrong here? And then we notice that, and then we say, okay, well, either that was a careless mistake, or that was something where there's like a gap in my knowledge. Number 3 sometimes presents itself as a spot where there might be a gap in our knowledge. Okay, so Jack, what do I do right off the bat here with dividing fractions? Yeah, very good. We're going to keep the first fraction. We're going to flip the second fraction. And we're going to change it to multiplication. You ever heard keep, flip, change, KFC? Kentucky Fried Chicken. Sometimes we hear it, silly fraction, don't be shy, flip yourself and multiply. Y'all ever heard that one before? Okay. The real reason that we do what Jack just told us to do is that division is defined as multiplying by the R word, reciprocal. Reciprocal means flip that fraction, doesn't it? So we flip 8 over 25, and then we start canceling out. And I notice again here that 4 goes into 12 thrice, it goes into 8 twice, 5 goes into 10 twice, and 5 goes into 25 5 times. So what am I left with? What are my answers? 15 over 4. Again, I think I heard somebody say 2. We'd multiply top with top, bottom with bottom. Okay? Let's see here. After yesterday's football games, who has made it to the Super Bowl there, Mr. Oxley? The Bucks and the Chiefs. All right. I don't know how it was the Bills game close. I didn't see the highlights of that. Wasn't close. Chiefs blew them out. Oh, yuck. Well, the Packers game was closer than I think the final score looked. They got down there at the end, and I don't know why they kicked a field goal instead of, they were down 8 with like a couple minutes to go. Maybe they thought they were going to get the ball back. But anyway, should be exciting. Does anybody know who is performing at the halftime show? It's another little OBQ kind of thing. Yeah, The Weeknd, whoever that guy is. All right. So give yourself a score, and this is just meant to be like a mental check for yourself. If you did well, kudos. If you did not well, then step up your game. Go back and practice over a little bit of this stuff. Teddy and I, my 9-year-old, last night we're having a little come apart because he's got a multiplication test today, and he's got I guess they're doing the 11s and the 12s today. And so he's been with me all weekend long. My wife and my girls were out of town visiting her parents. And so Teddy and I have been just doing boy stuff. We were working on a Pinewood Derby car. We were cleaning up the house, watching Star Wars. He watched Jurassic Park for the first time ever. Y'all seen Jurassic Park? Y'all know that movie? It's a little scary for a 9-year-old, so I had to cover his eyes up when the lawyer got bit in half and shook around by the T-Rex. But anywho, suffice it to say, he and I had a great weekend until last night. And he's getting his backpack ready for school today, and lo and behold, he tells me, hey, Dad, I got a quiz tomorrow on multiplication. And I said, oh, okay, well, let's see how you do. And he stunk it up. He did not do very well, okay? And so I just was like, oh, you've got to be kidding me, son. If you are weak on something, you got to practice it. Like Friday afternoon, we should have been practicing, and then a little bit more Saturday, a little bit more Sunday. Don't wait till the last minute, blah, 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 stuff like your mom and dad probably tell you all the time. But my point for you guys is that if you stunk on this quiz, if you made some careless mistakes, or if there were gaps in your knowledge, don't be like Teddy. Don't wait till it's too late. Practice a little bit now, okay? Start going back over some of these fraction type problems, all right? Now, as far as new material goes, we're going to talk a little bit in this chapter about the words rational versus irrational, okay? And these are probably words you've heard of before. But we want to make sure that we understand what a rational number is. This is a reminder, okay? Again, I know that we forget things sometimes. But when we look at the word rational, it means can be expressed as a ratio of integers, okay? So like the number 1/2 is rational because that's a ratio or a fraction of 1/2. All of those in blue are rational numbers. They're either terminating or repeating decimals, or they can be expressed as a ratio of two counting numbers. Okay. Irrational means I can't express it as a ratio of integers. Irrational means it's non-repeating and non-terminating. Okay, things like the square root of 2, things like pi or e, or some weird number that follows a pattern, but it's not like a repeating bar pattern. These are examples of what are called irrational numbers. Man, I'm getting toasty up in here, boys. Maybe that heater did not appreciate my throwing a pin at it. It's going to pay me back with a vengeance. All right, so when we talk, oh, go ahead, Tiago. E is sort of like pi. What's pi approximately, you guys? 3.14. E is approximately 2.71. It's an irrational number. It stands for Euler's number. Euler's a guy named Leonard Euler, famous mathematician. His name's spelled E-U-L-E-R, hence the lowercase e. But it's called the natural number or the natural base. It's approximately 2.71. That's all you need to know right now. Anyway, these are all examples of either rational or irrational numbers. And in this chapter, we're going to talk about operating with rational expressions. Now, a rational expression is a fancy way of saying what? A fraction. Y'all write that down. A rational expression. That's a fancy phrase for fraction. We're going to be doing operations with fractions in this chapter, okay? I tell students all the time in Algebra 1, I like to break down the year into sort of 3 chunks, the 3 F words. So we've got factoring, we've got functions, and we've got fractions, okay? 3 really large parts of our Algebra 1 curriculum. Well, you guys have talked about factoring a good deal. We've dealt with functions, and we'll continue dealing with functions throughout the rest of this semester. But here in this chapter, we're going to talk a lot about fractions or rational expressions. And what we're going to do is, instead of like in that quiz where they were, like mostly numbers on the top and on the bottom, they were all monomials, just one term, Quentin, on the top and on the bottom, right? We're going to start having polynomials on the top and on the bottom. And things are going to start looking a little bit tougher, okay? And so today, in this section, we're going to start, you tell the title is 7.1, multiplying and dividing. That's what we're going to do. We're going to practice multiplying and dividing. All right, a couple more little pieces of background info. Please remember that you can't divide by 0. It is an undefined operation. Again, this is a review. I write in red up there. Remember, just suffice it. You don't have to write everything down here. But man, just please say that you can't divide by 0. Dividing by 0 is undefined. Okay? It's hogwash. It's nonsense. It's like taking the snargle-puff of the homophilication. Okay, just don't make it. That's nonsense, Coach Morgan. What are you talking about? Same thing with divide by 0. We can't do it. Even 0 over 0, which some students might argue, well, that's 1, Coach. You got the same thing on the top and the bottom. Undefined. Anytime I have a 0 on the bottom, can't figure out what that is. 0 on top is okay. 0 on top is fine, like 0 over 5, 0 over 7, 0 over -3, whatever. All of those equal 0. But when the bottom is 0, it's undefined. I can't divide by 0. That's the gist of this page. Okay. We already talked about simplifying and taking out common factors. All right, we just got through mentioning. Let's look at this slide right here. We just got through mentioning what would make a rational expression undefined. And you guys said if the denominator equals 0. What would make a fraction equal 0 if the numerator equals 0? So really what we're looking at here, look at example 1 with me. We're given this function that's a rational function, it's a rational expression. You got x plus 4 on top, and you got that trinomial on the bottom. And the two little bullet point questions say, when does this fraction equal 0? Okay, well, I know that a fraction equals 0 when in simplified form, the numerator equals 0. What do I mean, Joe, by simplified form? What does that mean? Going back to the little quiz right at the very beginning, was that simplified? Were any of those simplified at the beginning? So what do you think I ought to try to do? Whoops, where am I? Oh, I went too far, didn't I? Yeah, there we go. Okay, so like, Joe, what do you think I should try to do here with my function before I start doing any kind of operations? I should try to start simplifying. All right, write that down, that we always, first step right out of the gate is to try to simplify. Now, I'm sort of setting the table for a little trap right here, okay? I'm laying out a booby trap, okay, Jack McBee? Laying out a booby trap. Beware. So I look at a fraction like this, and I think, gee golly, I sure would like to simplify that. I see an x on the top and on the bottom. I guess I can just cancel those two x's out, right? No. Good job. You guys didn't fall in my booby trap. Why not? What does that plus sign act as? Oh, block. Okay? We cannot cancel terms out. We can only cancel F word. Factors. Factors are things that are being multiplied. And how do I write something as a multiplication problem? How do I write something as a product? Factor it. Okay? So check this out. The numerator is already fully factored, isn't it? X plus 4, that's just a linear binomial. Can't do anything with it. But you look at the denominator, and we just spent a whole chapter practicing these. So I bet Joey's going to factor out the denominator for me. Jojo, go ahead. I would not use 6 and 1 because 6 and 1 would make 7. I would not use 6 and -1 because that would mean this 6 would have to be negative. Does 6 have another factor pair? What is it? Wrong. I would not use -1 and 6 because, again, -1 times 6 would be -6. What are two factors of 6 besides 1 and 6? Ding, 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 ding. Winner, winner, winner. 2 and 3. Good. Now that we've factored that out, right? Does anything cancel? Oh, good night, America. No. Are those the same factor? That's like saying A over B times C. Does anything cancel in that blue fraction? No. There are no common factors. So in other words, I realize there's a 4 and a 2, and we kind of look at those and we think, oh yeah, 4 and 2, that cancels out. No, this is the entire factor, and it has to match identically. There would have to be an x plus 4 on the bottom for me to cancel out the whole factor. We can't cherry pick and break through that roadblock. If there's a plus sign linking those two terms together, if I'm going to cancel part of one, I'm going to have to cancel the whole shebang. Right? So we have factored the first, done our first step by factoring the top and bottom. Nothing cancels out, so we are simplified, as we were talking about a minute ago. Now I want to know, when in simplified form, which we've got in green there, what would make my numerator equal 0? Charlie, do you have a number? Yeah, if we take that numerator and set it equal to 0 and solve, x equals -4 would make my numerator equal 0. That answers that first question. When does the whole fraction, the whole kit and caboodle equal 0? Why, when x equals -4. Okay, Lewis, when would the fraction be undefined? In other words, what would make my denominator 0? Lewis, I can't hear you. Try and say something.
When
There we go. I can hear you now.
x is -2.
All right, good. So when x is, let's see if I can write this down here. When x is -2, any other place?
Or -3.
That boy. When x equals -3. Can you guys see why it's important for us to be able to factor now? So that we can use the ZPP and we can set the numerator, or in this case, the denominator, equal to 0 and solve. All it takes is a little bit of factoring, and then we set each individual factor equal to 0. That's how you can tell when a rational expression equals 0, when the top does, or is, or is undefined when the bottom does. Savvy? All right, let's try another one. Okay. The numerator and the denominator are already factored out on this one. There's no factoring that I have to do. Nothing cancels. Please don't be that goober that says, oh, look, an x on top and an x on bottom. Why not? Roadblock. Okay? That x is tied in with the 4 and the 3 on top. That x on the bottom is tied in with the 2 and a 5, and nary the two shall be separated. All right? But when does this fraction equal 0? When the numerator equals 0. Okay, James, what would make my numerator equal 0? Solve that little two-step linear equation. Can you add 3 to both sides? That's 3. And can you divide by 4 on both sides? And get x equals 3/4. That's what we're talking about there. So like you guys have heard me say this expression before, I'm going to push you to be able to solve some basic linear equations. Those steps, I've been pushing you guys to like solve them in your head, right? You guys heard me say that expression. So when we are doing this, well, like for example, in the second one, Reed is about to tell me what x value would make this function undefined. He's going to solve the denominator set equal to 0. Okay, and I'm pushing you to do that step in your head. Actually, 2 steps. So Reed, go ahead. What do you think?
-5/2.
X equals -5/2. Perfect. If you want to show your steps, kind of like I did on the numerator, that's fine too. Not a big deal. But what we have found is that x equals 3/4 will make the fraction equal 0, and x equals -5/2 will make the fraction undefined. Okay? I think you guys need to try one on your own. There you go. Example 3 is all yours. Where does the fraction equal 0? And where is the fraction undefined? And I'm going to throw it back to what Joey and I were talking about a minute ago with factoring that denominator. Be careful how you factor. The 6 is now negative. And remember, also, we are supposed to simplify everything first. Simplify everything first. Quentin? Oh, absolutely, my man. I got my second vaccine yesterday, or excuse me, Saturday. And so now I'm fully vaccinated, but unlike the first vaccine, the second one kind of, let's say, made me feel bad, but I just did not feel like myself. Apparently that's my immune system fighting whatever fake stuff they put in the vaccine to trick my immune system into learning how to fight it. But I pretty much laid around all weekend long. You guys ever do that? Y'all ever just have like a lay around all weekend kind of thing? That's all you do? It's like I said, my wife and daughters were out of town, so it was pretty much just like Teddy and I laid around and watched some shows and took some naps, and yesterday went to church, and then played around with the Pinewood Derby a little bit. But other than that, it was a very restful weekend. I went to bed last night about 9:15. Y'all ever go to bed super early? Feels good. I went from 9:15 to 6:15. How many sleep hours is that? That's like 9 hours, isn't it? Yeah, that's pretty good. Pretty good. All right, Grove, what did you do first on this problem?
I'm distributed the x on the bottom, or x squared on the bottom.
When you say distributed, I don't know what that means in this context. Did you write it as a product on the bottom?
Yes.
You then that's what is called factoring. So you factored the bottom. All right, how did you factor the bottom?
X.
Minus 2 and x plus 3. Very good, very good. Okay. Do any of those factors cancel out? They don't. Okay. So Alex, where would the fraction equal 0 when x is what? When x is positive 5. And my other Alex, when would the fraction be undefined? In which case we have two answers. What are they? Mm-hmm. Correctamundo. Very good. You guys get that? Y'all understand? All right. What makes a fraction equal 0 is when the top equals 0. What makes a fraction undefined is when the bottom equals 0. Basic fraction knowledge that we got to have. Okay? Any questions before we move on? Okie dokie, artichoke. Now, we talked a little bit about this. Let me pull this up here. Yeah, there we go. So my next slide, I'm gonna zoom in a little bit better so y'all can see the whole thing. What's up top we already know about. What's up top we talked about in the warm-up, how like we can cancel common factors. And I wrote it up in big all caps rage with lots of exclamation points, so you better daggum write it down on your end. Do not cancel terms. Terms are separated by a plus sign or a minus sign, which act as a roadblock. Don't be canceling terms out. It is so dadgum tempting. Look down here in blue at the bottom. It's so tempting for us to see an x squared on the top and an x squared on the bottom. We think, ooh, yay, I'm going to cancel that. Wrong. Don't do it. I used to fall into that temptation all the daggum time when I was a student. It was so tempting. I see an x squared on the top, x squared on the bottom. I would just get all happy and start canceling, and I would get it wrong. It would be really frustrating because I didn't realize you can't cancel terms. And if you don't know what the difference between a term and a factor is, you better daggum learn it. A term is something that's added or subtracted. A factor is something that's multiplied. Now, if it's factored out, as this one right up here near where we're doing it in red, if it's factored out, then that's gravy, man. You go cancel, cancel, cancel till your little heart's content. Right? We only cancel factors, so x minus 3 and x minus 3, a 5 and a 5. You know what I'm saying? We don't cancel x and then the x down here because that x down here is tied in with the 2 plus sign roadblock. Got to cancel the whole factor. Okay? But up at the top in gray, that's sort of, bless you, that's sort of like our background for what we're doing. And I tell students all the time, you multiply the top with the top and the bottom with the bottom, but you can always cancel common factors first before you do any kind of multiplication. Okay? So, let's practice simplifying. I don't reckon that we'll have much more time other than just example 4, but let's do example 4 here. All right, write this one down, and then I think the lesson will be yours. We got x squared plus 5x plus 6 on top, and we got x squared plus 8x plus 12 on the bottom. Now, first thing I'm gonna do right out the gate, Nate, is what? Oh gosh, dog it. Nate, are you joshing me? Are you joking? Are you kidding me? What did we just say? What did I just tell you was a temptation that I used to fall prey to that we should not do? We should not cancel out terms, which are things that are added subtracted. Boo bad, Nate. Try again. What should I do first? Write it as a product. In other words, factor the top and factor the bottom. George, can you factor the top for us real quick? Oh, 6 is positive, so I need 2 positive factors. Thank you, sir. So x plus 3, x plus 2. Okay, Tiago, can you factor the bottom? X plus 6 and x plus 2. All right, fabulous. Paul, do you notice what I should do now? Because I see x plus 2 on the top and on the bottom as an identical factor, I can now cancel it out. And what's my simplified result? It's x plus 3 over x plus 6. Why can I not go further and cancel out the x's on the final little result there? Why can't I cancel a 3 and a 6? Roadblock. Those are terms. Those are terms. Hey, we'll do more of this tomorrow. Suffice it to say, we're going to be dealing with a lot of fractions in this chapter. Y'all get used to it. Get ready for it. Live Jesus in our hearts. All right. Thank you, fellas. I'll put up a Delta Math assignment for the week, probably today sometime, so y'all can check online for that. A little bit of some practice opportunities. And I'll see y'all tomorrow morning.